Hello, and welcome to the Mom Teaches Tech video series for Cisco NetAcad's Introduction to Networks. This video series is designed to supplement the Cisco Networking Academy ebook, Introduction to Networks, that is used by many Cisco Networking Academy instructors. In order to access this material, you must be enrolled in a Cisco Networking Academy course. The material in Cisco NetAcad starts off basic and increases in difficulty and complexity as you move through the series of classes. There are 3 classes in this series, and as I said, this is for the first course, Introduction to Networks. Whether you're a student or an instructor or someone who is just interested in learning more about networking, you're welcome to use this material. Let's continue with Module 1 of Cisco NetAcad Introduction to Networks. Most of the terminology in Chapter 1 is used throughout the rest of the material in NetAcad, and it's foundational for understanding networking concepts. First, let's take a look at what we're actually going to call the devices that you find on a network. At the most basic level, you have hosts. And within the broad definition of hosts or end devices, we have 2 types of devices, which are either clients or servers. Servers are computers that provide information. There can be email servers, web servers, file servers, Active Directory servers, many different types of servers. And then clients are computers that send requests to the servers to retrieve information. Okay, now let's talk a little bit about ports, NICs, or network interface cards, and interfaces. The basic difference between a port and an interface is that a port is physical. You can reach out and touch a port or insert a cable into a port. An interface may be software-based and not exist as a physical port on a device that you can touch. Having said that, people call ports interfaces
metal wires
all the time.
within cables.
Now, the term
don't
NIC,
have to have an
NIC is going to be used often
They
in
can
your
be
studies.
electrical.
NIC stands for
I
network
like to use
interface
this
card.
single board
Glass
or
NIC
plastic
is a
fiber
physical
optic
card,
here
also
that is
associated
quite a bit
with the devices,
wireless NIC
connection
media
to the
travel
internet
here
across
on the
network
Raspberry
fiber optic
Pi,
whether
cables,
that uses
be
pulses
a
of light to
wireless
represent
or
the
wired
connection.
spot on the
And
Raspberry
wireless
Pi,
transmission
which will
is
go on
very
to see what a
common.
network
Wireless
interface card
transmission
looks like.
uses modulation
physical
to
for
specific
for a
frequencies
wired
across
one that's
electromagnetic
installed
waves
in
to represent
separate
the zeros and
network
ones.
and you can see
Now,
this is
a lot of people think
connection
about these
wired. It has an
intermediary
RJ45
devices
connector
when they
here,
think
and one
about
of them you would
networking,
see
is
on
or if you're
wireless
very
side of your
new to the
computer.
topic, moving on to
you might
network
not think
media.
about these
Communication
devices at
from
all,
a device,
but these are
has
really
to
what we're going to be
travel
learning to
through the
configure
network
in
some manner.
Cisco NetAcad classes. So an intermediary device, what is it? Well, it connects end devices together. Examples include switches, wireless access points, routers, and firewalls. Intermediary devices can manage data as it flows through the network, providing security, regenerating and retransmitting data signals, maintaining information about what pathways exist in the network, and intermediary devices can also notify other devices of errors and communication failures. Just do a Google search for Cisco switches and you can see some here. Also, take a look at some small business routers, some physical firewalls that you could have on the network. These are WatchGuard brand. I like using this slide because they're red, which is great. I did used to have a WatchGuard firewall in a business that I managed, and I liked it because it was red. What can I say? Well, I'm sure you realize that networks come in many different sizes, but we have to have a way in network engineering to talk about the different sizes of networks rather than just saying big, small, medium. and also discussing the different ways that these networks function. So of course you can have small home offices or a SOHO, what's called a SOHO network, which stands for small office, home office. And then you can have medium to large size networks and of course worldwide networks as well. In a home setting or a SOHO network, you may have peer-to-peer networking. This is just simply where devices connect to each other, and one device might be acting as, say, a print server and offer printing services to other devices on the network. And then you might have one device that has all of your files stored on it, and it could be acting as a file server. Well, at any given time, each device could be acting as a server or as a client. So for example, if this laptop here is requesting print services from the PC that's connected to the printer, then the PC connected to the printer would be acting as the print server and the laptop would be acting as the client. You can see there's some advantages to a peer-to-peer network. They're easy to set up. They're not very complex. The cost is minimal, and they can be used for simple tasks if that's all you need to do. So, printing and sharing files. And then you can see here we also have some disadvantages listed. And the disadvantages is there's no centralized administration. It's not a very secure system, not scalable, meaning it's not easy to expand or grow, and it can have slower performance. Another common type of network is a client-server network. As we move to larger networks, peer-to-peer networking will not be efficient enough or secure enough for a network that's very big at all, really. Even for many small home office, so SOHO networks, using peer-to-peer networking, it might not take care of most of your needs, especially if you have a lot of storage needs. In many home offices today, and almost all business offices, we see the more robust client-server network being used. The advantages of a client-server network include centralized administration, security services. They're able to grow and expand, so scalable, and multiple people can access data at one time. The disadvantages are you must have skilled staff to set up and maintain most client-server networks. That costs more, so the equipment might cost more. The equipment costs more, and the people to manage the equipment is also a cost factor. There is a potential for a single point of failure in your server if you don't have redundancy or backups built in. And there is potential for network congestion, especially if your network wiring is old and needs upgrading, or your intermediary devices are also not functioning at full potential or need updating as well. And again, that comes into cost, really. Another set of terminology that we use to classify networks is by local area networks and wide area networks, or LANs and WANs. These are the two most common types of networks. A LAN is a network infrastructure that spans a relatively small geographical area. So a SOHO network or your home network would be a LAN. A LAN could be on a college campus as well. So LANs encompass quite a few networks that we've already talked about. Now, a WAN, or wide area network, is network infrastructure that spans a wide geographical area. So the internet itself is considered a WAN. Companies that have offices in multiple locations are considered WANs. If we look at the graphic here from the NetAcad material, you see that this particular company consists of several local area networks, or LANs, and also has a wide area network that connects all of the LANs to each other. Also, as we're talking about types of networks, it's useful to mention here that some other network terminology that you may run across are metropolitan area networks and personal area networks, or MANs and PANs. Cisco NetAcad no longer covers MANs or PANs in Chapter 1, but they do use the terminology later in the ebook, so it's helpful to understand and introduce these concepts and terminologies here while we're covering types of networks. MANs can be somewhat confusing, so I don't really care for it as a term because there's debate about what a MAN is. It can either refer to one company that has multiple offices interconnected in a city, or it can refer to high-speed internet connections that are provided by a city to all the businesses in the area. That would be, a city promoting itself as having a high-speed infrastructure to attract businesses to the city. Personal area network, a PAN, is relatively easy to understand because this is all of the devices connected to and communicating on a single person. So you might have a phone and a smartwatch, or you could have a medical device implanted in your body. So you can have things for diabetics or Parkinson's disease, medical devices that are actually surgically implanted in someone's body and monitored on that person or by handheld external device. And those are considered personal area network devices. All right, now we have to have ways to actually visualize a network. We use network diagrams. They use symbols to represent devices within the network. Most network software that is used for diagramming networks stays fairly consistent with regards to how end devices, intermediary devices, and network media is represented. For example, when I am drawing a network router, I almost always represent it as an oval or circle. And when I draw a switch, it will be a rectangle. Firewalls typically are shown with bricks at the bottom to signify a wall. And then here for media, WAN links will have this little lightning bolt. And sometimes wireless just has this type of radiating pattern. And it also can be drawn as the squiggly line. There are two main ways to draw out a network, either as a physical or logical diagram. Here we have a physical topology diagram. The key with a physical diagram is it will always list the location of the device, such as the room number or a rack that the device is located on. In this image, we have a logical topology, and you'll see the scheme for the network. We have IP addressing listed here, which we'll get into much more detail later. We have port numbers also listed, and you'll see that it's really not listed where the device is located in the building for a logical representation. All right, I want to thank you for watching on my YouTube channel, Mom Teaches Tech. I'm just starting out on this journey. I've made video recordings of lectures for years, but never for the public to view. If you didn't enjoy the video or you see ways for me to improve it, maybe the sound was horrible, and I'll apologize. I have a cold right now, so the voice is pretty scratchy. But yeah, I really appreciate you watching this video. Kind of a very basic video. NetAcad starts out pretty slow and then ramps up fairly quickly, but do try to remember all of the terminology we covered here, and I hope to see you in the next video. Bye-bye.